Good day, learners. Today we are going to discuss Pythagorean Theorem. But before anything else, do not forget to like, share, subscribe, and hit the notification bell so that you will be updated for my upcoming videos. This video lesson will discuss about how to solve right triangle using Pythagorean Theorem. The Pythagorean Theorem was one of the earliest theorems known to ancient civilizations. This famous theorem is named for the Greek mathematician and philosopher Pythagoras. Pythagoras founded the Pythagorean school of mathematics in Cortona, a Greek seaport in southern Italy. He is credited with many contributions to mathematics, although some of them may have actually been the work of his students. The Pythagorean theorem is a statement about triangles containing a right angle. And the statement is, the area of a square built upon the hypotenuse of a right triangle is equal to the sum of the areas of the squares upon the remaining sides. And the equation of the Pythagorean theorem is the square of A plus the square of B is equal to the square of C. The Pythagorean theorem will be proven using this illustration. So as what you can see, there are three squares with different areas. The first square has an area of 9 because this is a 3 by 3 square. And the second square has an area of 16 because this is a 4 by 4 square. And the third square has an area of 25 because this is a 5 by 5 square. As what you can see, the triangle formed in the middle is a right triangle. So let us identify the parts of the right triangle. So these sides are what we call the legs of the triangle. And this side is what we call the hypotenuse because this is the longest side of a right triangle. And if we're going to check now, this side is the opposite of the 90-degree angle. And take note that hypotenuse is always the longest side of a right triangle. So let us now prove the Pythagorean theorem using the lengths of the sides of the right triangle in relation to the squares. So we are going to let now that this side, the 4, will be our A, and the 3 will be our B, or vice versa. And always remember that the hypotenuse is the longest side of a right triangle and opposite to the 90-degree angle. Then we can say our C is 5. So as we are going to substitute now the values of the sides of the triangle, so our A is 4, so that becomes 4 square. Our B is 3, so that becomes 3 square. And our C, which is the hypotenuse, is 5, so that becomes 5 square. So as we are going to simplify now, the 4 square is 16 plus the 3 square is 9 equals to 5 square, that is equal to 25. So if we're going to get now the sum of 16 and 9, that is equal to 25, which makes the equation correct. We already proven that this equation, the Pythagorean theorem, is always correct for every right triangle. Example number 1. Solve the unknown side of the triangle in the illustration. As what you can see, we have here a right triangle whose the two legs are given, which is the 5 and 12. And the hypotenuse C is unknown. How to solve this triangle? First is we're going to let A be equal to 5 and B be equal to 12. And we are looking for the C. Since this is a right triangle, we are going to use the Pythagorean formula, which is A squared plus B squared is equal to C squared. Then we are going to substitute now the value of our A and B. So A squared becomes 5 squared plus, and the value of our B is 12. Substituted to our B, that becomes 12 squared. Then we're going to copy C squared. So as we're going to simplify now, the 5 squared is 25. Because that is 5 times 5. And the 12 squared, which is 12 times 12, is equal to 144. Is equal to C squared. So as we are going to get now the sum of 25 plus 144, that is equal to 169, which is equal to C squared. And take note that we are not looking for the C squared. We are just only looking for the C. How we are going to find out the C if we have now C squared? We are going to extract square root both sides of the equation. So the C squared becomes the square root of C squared, and 169 becomes square root of 169. And take note that if you're going to get now the square root of the C squared, that is equal to C, and the square root of 169 is equal to 13, because 13 times 13 gives us 169. Then we can say that the value of the C or our hypotenuse now in the given triangle is equal to 13. Example number 2. Solve the unknown side of a triangle in the illustration. So this is our illustration whose a triangle unknown for the one leg of a right triangle and the other leg measures 9, and the hypotenuse of the right triangle in the illustration is 15. So what are we going to do is we are going to let A equal to 9 and unknown for the side B, the other leg of a triangle, and the hypotenuse is equal to 15. So since now this is a right triangle and we're going to solve one side of a right triangle, we're going to use the Pythagorean Theorem. So by substituting the value of our A, which is equal to 9, and the value of our C, which is equal to 15, and unknown for B, so we have A squared becomes 9 squared plus, copy the B squared, equals, the C squared becomes 15 squared. So simplifying further, the 9 squared become 81, because that is 9 times 9. Copy the B squared, equals the square of 15, that is equal to 225. Since we are looking for the B, we need to isolate now the B squared in the left side of the equation. So the 81 must be transposed on the other side. And take note that if you're going to transpose now one term from one side to the equation to the other side, always change the sign. So since now 81 is positive, if you're going to transpose this in the other side, so positive 81 becomes negative 81. So we already now isolated the b squared. So if we're going to subtract now or get the difference between 225 and 81, that is equal to 144. And take note that we are just only looking for the b, not the b squared. So in order for us to omit now the square of the b, we are going to extract square root both sides. So b squared becomes square root of b squared, then the square root of 144. Simplify now the square root of b squared, that is equal to b, and the square root of 144, that is equal to 12. Then we can say the measure of the other leg of a right triangle in the illustration is equal to 12. Example number 3. Solve the unknown side of a right triangle in the illustration. So this is now our right triangle whose hypotenuse is 60 and one leg of a right triangle is 48 and unknown for the other leg, which is the x. So first thing we need to do is we are going to let A be our x and let B be equal to 48 and let C be equal to 60. So using the Pythagorean Theorem, substituting the value of our A, which is x, the value of our B, which is 48, and the value of our C, that is equal to 60. So the equation now, as we are going to substitute now the values of our A, B, and C, it becomes x squared plus 48 squared is equal to 60 squared. So just only copy x squared and then simplify 48 squared. So if you are going to get now 48 squared, that is 48 times 48, that is equal to 2304. And the square of 60, which is 60 times 60, that is equal to 3600. So all we need to do is we are going to isolate now the x squared by transposing now 2304 on the other side. So and take note that 2304 is a positive term. So if you're going to transpose it on the other side, it becomes negative. So the equation now is x squared is equal to 3600 minus 2304. So if we're going to get now the difference between 3600 and 2304, then x squared is equal to 1296. And take note that we are just only looking for the x, not the x squared. So we need to extract square root both sides in order for us to omit the square of the x. So the equation becomes square root of x squared is equal to square root of 1296. So simplifying further, square root of x squared is x and the square root of 1296 is 36. Then we can say the measure of the other leg of a right triangle in the illustration is equal to 36. Example number 4. If the square of the hypotenuse of an isosceles right triangle is 128 square centimeter, find the length of each side. As we are going to illustrate now the right triangle in the problem. So when we say isosceles triangle, the two legs of a right triangle are equal. So we have now, so we are going to label it as x since they are equal. So the other side must be labeled as x also. Okay, because they are equal. This side and this side are congruent. It means they have equal measure. And then this is our hypotenuse C. So to solve now the problem, so let A be equal to x and let B b equal to x also, since they are equal. It has been said in the problem, square of the hypotenuse of an isosceles right triangle is 128 square centimeter. It means that the 128 square centimeter means the value of the hypotenuse must be multiplied to itself. The square of the hypotenuse now is 128 square centimeter. So as we are going to use now the Pythagorean, so substitute now the value of our a, which is equal to x, the b equal to x also. So the equation becomes x squared plus x squared is equal to, then the value of the c squared, so x squared plus x squared becomes 2x squared equals 128. Next is we need to isolate now the x squared by dividing both sides by 2. So 2x squared becomes x squared, and then 128 divided by 2, that is equal to 64. So we have now x squared is equal to 64. Next is extract square root both sides, so that now we could isolate only the x. So it becomes the square root of x squared is equal to the square root of 64. So it becomes square root of x squared is equal to x, and the square root of 64, that is equal to 8. Then we can say that the length of each side of this isosceles right triangle are equal to 8. Example number 5. Find the perimeter of a rectangle whose length is 150 meters and the diagonal is 170 meters. So as the illustration, this is our rectangle whose length is 150 meters, then unknown for the width. And it has been said also in the problem that the diagonal of this right triangle is 170 meters. So we are going to label this as 170 meters. And then take note, if we're going to cut now this rectangle into two by its diagonal, then we can form a right triangle, okay, whose the width is the one leg of a right triangle and the length is the one leg of the right triangle, and the diagonal becomes the hypotenuse. Since we are looking for the width of a rectangle, in order for us to get now the perimeter, this now the total side of this rectangle, we're going to solve now the width using the right triangle. So we're going to let now A be the width or the W, and then our B be the length, which measures 50 meters or 50, and then our hypotenuse, which is the C, which is the diagonal of a rectangle, is 170. So solve the width of a rectangle using the Pythagorean theorem. Okay, so we have now a squared plus b squared is equal to c squared. So substituting the value of our a, which is the w, that becomes w squared. And substituting the value of our b, which is 150, so that becomes b squared becomes 150 square. And substituting the value of our c, which is 170, then c squared becomes 170 square. So as we are going to simplify further the equation, so just copy w squared and then simplify 150 square, that is 22,500, equals, then simplifying now 170 square. So 170 times 170, that is equal to 28,900. Then we need to isolate now the w squared in the left side of the equation by transposing 22,500 on the other side. So the equation now becomes w squared equals 28,900 minus 22,500. So if we're going to subtract now this one, the 22,500 to 28,500, that becomes 6,400. Or that becomes w squared is equal to 6,400. So in order for us to isolate now the w, or by omitting now the square of the w, we need to extract square root both side of the equation. So it becomes square root of w squared is equal to the square root of 6,400. So simplifying further, the square root of the w squared is equal to w, and the square root of 6,400 is equal to 80. Then we can say the width of a rectangle measures 80 meters. In the problem, we're going to find the perimeter of the rectangle. So in finding the perimeter, we're going to use the formula P is equal to 2L plus 2W. Or in other words, perimeter of a rectangle is equal to twice the length plus twice the width. And substitute now the value of the length, which is 150 meters, and the width, which is 80 meters. In the formula, so the formula becomes, so as we are going to substitute the value of our length, which is 150 meters, so 2L becomes 2 times 150 meters plus 2W. 2W becomes 2 times 80 meters. So simplifying further, we have 2 times 150 meters is equal to 300 meters plus 2 times 80, that is equal to 160 meters. Then as we are going to get now the sum, or add now 300 meters plus 160 meters, the perimeter is 460 meters. Then we can say that the perimeter of a rectangle is 460 meters. Example number 6. A ladder 13 meters long is placed on the ground in such a way that it touches the top of a vertical wall 12 meters high. Find the distance of the foot of the ladder from the bottom of the wall. So as we are going to illustrate now, this is the vertical wall that is 12 meters high. And this is now the ground, which is the unknown, and the length of the ladder, which is 13 meters. So as what you can see, illustration associate to a right triangle, because this is a vertical wall. This measures 90 degrees. The ladder becomes the hypotenuse of the right triangle, and the wall and the ground are the legs. The problem asks for what is the distance of the foot of the ladder from the bottom of the wall. So this is now the ground. In short, the ground where the ladder placed towards the wall. So solution, let A be the length of the wall, that is equal to 12, and the B, which is now the distance of the ladder from the bottom of the wall, which is the ground, and the C, which is equal to 30, which is the length of the ladder. So since this is a right triangle, we are going to use now the Pythagorean theorem by substituting the value of the A, B, and the C. So it becomes 12 squared plus x squared is equal to 13 squared. So as we are going to evaluate or simplify 12 squared, it becomes 144. Just copy x squared and the square of 13, that is equal to 169. Then isolate now x squared by transposing 144 on the other side. So it becomes x squared is equal to 169 minus 144. So if we are going to subtract now 144 to 169, so it becomes 25. Then we can say x squared is equal to 20. So in order for us to isolate now the x alone, we need to omit the square of the x by extracting square root both sides. So it becomes square root of x squared equals square root of 25. So as we are going to simplify further, square root of x squared becomes x, and the square root of 25 is equal to 5. Therefore, the distance of the foot of the ladder from the bottom of the wall is 5 meters.
And that ends our video discussion at this moment. Thank you for watching. But before you will end this video, please do assess your learnings by answering the self-test activity. Thank you.